like that, correct? Yes. And this vector is
that, you know that I10.
That thing goes into
yeah.
Okay. Hello class. For today we will be going through the questions for A Level H2 Mathematics 2020 paper 1. Okay, paper 1. You can see it's here, right? Paper 1. It's a 3 hours paper, but we will split into every single question. So, okay, each video will contain one question. Okay, let me zoom in. This is just a 4 marks question, as you can see, 2, right? It looks simple. First of all, let's invite Akina to to read the question and try to explain.
A plane pi 1 contains two vectors, 1, 1, 0 and 1, negative 5, negative 2. Find a vector normal to pi 1.
Okay, the key word here is normal, right? Okay, so if this is a plane pi 1, there will be two vectors, correct? And let's say this is vector A, this is vector B. We can just take any two random vectors pointing to any direction. Of course, this is supposed to be the directions, right? But I won't go into details how to draw them exactly, right? So A and B. The new vector, which is normal to pi 1, how can you deduce this vector?
I don't know.
If you imagine this, if you put this one, we are like seeing this thing as our top view, right? If we look at it like this, okay, this is pi 1. How would you draw a vector that's normal to pi 1? Normal. The keyword normal.
Like you draw 90 degrees.
Yes, so you draw a 90 degree vector which is like perpendicular, okay, perpendicular to the plane. So if I have a plane, the vector will be like that.
Okay.
Right? Understand?
Yeah.
Okay.
So that's the plane.
Right? If this is a plane, if I have a vector like that, I have a vector like that. If I'm to look out for a vector which is normal to the plane, the vector will be like that, correct? Yes. And this vector is perpendicular to the plane and perpendicular to these two vectors. Oh. Actually, any vectors in the plane will be perpendicular to the normal vector.
Okay.
Understand the concept?
Yes.
Okay. Makes sense, right?
Yes.
Okay, so that means this vector normal to pi 1, which will be perpendicular, or maybe I should just draw this, perpendicular to A and B, right? So this deduction will actually tell us that if we were to let n be the normal vector, n will be the cross product of A and B. Can you understand? Right, this is a concept that you should know, okay? So, next thing, A and B. Wait, your A is 1, 1, 0. Your A is 1, 1, 0. Your B is 1, negative 5, negative 2. 1, negative 5, negative 2. Right? If we were to write in a vector form, which is A equals to I plus J. Can you understand? Plus 0K, right? So B equals to I minus 5J minus 2K. Alright, so that gives us A cross B, which is what we need to find, which is N, right, equals to this one, okay? This is standard procedure IJK. Then we list it down 1, 1, 0, 1, negative 5, negative 2. Okay? I hope you don't forget how to do cross product. Right? This is just listing down, and then the process will just follow. I minus j plus k. Okay? So how do we do this? If we were to cover the I column and row, we will have these 4 numbers left. So we can just 1, negative 5, negative 0, negative 2. Okay? So this is how we do it. When we look at the second j, right? We'll cover this one and cover this one. You have 1, 1, 0, negative 2. For k, same thing. Cover, cover. You have this 4. 1, 1, negative 5, 0. Okay? Then come to this one.
Why negative 5 and 0? Covering k.
Oh, sorry. Yeah. Negative 1, negative 5. Sorry, that's my handwriting problem. Yes. Good. Okay, good. You notice that. So it's 1, negative 5. Okay, so another thing is, if we were to...
Huh? I don't understand.
Which one?
You're covering
K.
k.
Yes. K and this.
Oh, okay,
Yeah.
sorry.
So you
it's
have...
very confusing, your
Handwriting, is it?
yeah, the representation, because yeah.
Which part is confusing?
No, it's not confusing. It's just that you know that I 1, 0.
That thing goes into it,
Yeah.
right? Okay. Maybe I should just like move it closer. Right. Okay. I 1, 1. Oh no, 0.
0.
Yeah. Okay. That's clearer, right? That's clearer. Okay, so now it comes to this part, like how do we deal with this one? It's also very standard. Okay, so which means if we have A, B, C, D. Okay, this A, B doesn't have the tilde behind,
Is
like
it
below.
a mod sign or a bracket?
Mod sign, sorry. Yep, mod sign. Okay, so this equals to, what does this equal to?
No, are you supposed to do?
You don't know?
I don't know.
So go down and go up, right? So this equals to AD minus BC.
Okay.
So by calculation, I bracket 1 minus 2 is a minus 2, correct? Okay, negative J minus 2 minus 1 times 0 is 0, so minus 2 again, plus K 1, negative 5, 1, 1, minus 1, right, which is minus 6. Therefore, the final answer will be minus 2i plus 2j minus 6k. Okay, which is the same as n equals to minus 2, 2, minus 6. Okay, so this is the vector normal to pi 1.
Okay.
Got it?
Yeah.
Right, okay, good.
Very clear.
So here is another plane now. Okay, another plane pi 2 has an equation, this one. Okay, find the acute angle between pi 1 and pi 2. It's just like if you have this one and you have this one, actually it's like to find the angle here, something like that. Kind of.
Don't get it.
Yeah, I mean if you are to intersect these two plane. You see, if you were to intersect plane 1, plane B, if they were to intersect, they have an angle in between, acute angle. Can I understand? Like I can see. Okay, the plane can only be defined, right? A plane can only be defined by a specific vector. There's one vector that actually can define the plane, that tells you where the plane actually is. Which vector is that?
Sorry. Can you repeat?
A plane is a collection of vectors, right? It has a lot of vectors lying in it, right? But there is one specific vector that actually defines the plane.
Oh.
What vector is that?
I don't know.
The normal vector.
Okay.
Because imagine this plane has so many vectors. You can pick any vector, but that doesn't define this plane.
Okay.
But this one, this vector is fixed, correct? But it's only fixed. There is only one vector that's perpendicular to the plane.
But you can have a lot of vectors perpendicular to the plane.
This is a plane, correct?
Okay.
The perpendicular vector, which is a normal vector, is like that, right?
Yeah.
Regardless where it is, it's always a multiple of this one.
A multiple of which one?
This one. Anyone. As the normal vector, any cross product of cross product of any two vectors inside the plane.
Also, any two vectors inside the plane, if you do a cross product, will give you the normal, correct?
Correct.
But then you can have a lot of different vectors on the plane.
But the normal will always be multiple of each other.
Of each other of what?
The normal vectors are.
So the normal vector times the normal vector?
No, a multiple scalar product of any normal vectors. All the normal vectors will be a multiple of each other. What's the meaning of multiple?
No, multiple of what? Which multiple? Which one?
Okay, you take two vectors in this plane, these two. You have a normal vector like that, right? If you take this one and this one, you have a vector like that, right?
Correct.
But these two are multiple of each other. You can always simplify it to the, you can always...
So that normal times this normal will become what?
No, you don't times. This one is multiple of this one.
Oh, yeah. Wait, why?
8 is a multiple of 4. Right?
No, but why this is the multiple of this?
They are always parallel to each other. But the vector inside this one, they may not be parallel.
Yeah, I know.
You see, that's why the only vector that defines this plane, to locate this plane, is the normal vector. That's why there's formula like this, the equation. A plane has an equation of this. So if you write this one, 4, 5, -6. This will be a normal vector. This is your normal vector of your plane. This is the only one that defines this plane.
So all the normals will be parallel to each other?
Yes, correct. Be it this direction or that direction.
So how is this information useful?
To define the plane. To write the equation of the plane.
Oh.
Got it?
Yeah.
Okay, so when you have two planes, a plane like that, imagine a plane like that and a plane like that. So when they intersect, okay, they will like intersect like that, right? So there is an acute angle, right? Can you see?
Yeah.
Where is the acute angle? It's like between my fingers, right? It's like here, from like here, right? Okay. So this is a normal vector for pi 1, correct? Normal vector for pi 2 is, what's that? 4, 5, -6, okay? By 4, 5, -6. Okay, so we know if we have two vectors, the dot product, okay? This comes with a dot product formula. Of course, you can use cross product, but dot product is much easier to use because I always think I dislike the formula of cross product. Yeah, I just don't like the formula for cross product. It's too much things to handle. Okay, so this thing by formula n1 dot n2 equals to the length of n1 and the length of n2 multiplied by cosine theta, and this theta is the angle between the vectors, between the two vectors.
You mean the two planes?
No, vectors. Between the two vectors. Why?
Which two
Yeah,
vectors?
like you will be asking why the question asks for the angle between the two planes, and now you are talking about two vectors, right?
Yeah.
Because as I said, this one defines the plane, right? If the two planes have the angle, the normal vector their normal vectors will also intersect at the same angle.
Yeah.
Correct? Understand? Because 90 degrees, everything, right? So therefore, I can take this.
But what do you use cosine?
I don't use cosine. It's just that I prefer the dot product formula.
So
You can also use
What is the cosine?
cosine.
Yeah. Why
This is by formula. You don't have. I don't have to explain. I don't want to
the
explain.
formula is always cosine.
Yes, for dot product.
So there is no other exception that you will be assigned.
No,
So it's always cosine.
unless if you do an n1 cross n2. This will be n1, n2, sine theta.
Oh.
Yeah, so these two formulas. Of course, why do I choose dot product?
Because you don't like cross product.
Yeah, it's too much calculation. Why would I do that?
Okay.
Too much thinking. N1, n dot, n2. That's so much easier to calculate. I can do it without using calculator. Right. Okay. So -2 to -6 dot 4, 5, -6 equals to square root of length of n1. What do you do?
I don't know.
n1 is here. Length of n1. Come on.
What? -2 plus 2 plus -6?
Don't act. Okay, -2 square, which is 4, plus 2 square, which is 4, plus 6 square, -6 square, 36. Okay, multiply by square root of n2 square, 4 square, 16, 5 square, 25, -6 square, 36. Okay, cosine theta. Alright, so this one, give me an answer for this.
I don't know.
Dot product.
I don't know.
This one multiplied by this plus this one multiplied by this plus this one multiplied by this. So you have a -8
8.
plus 10 plus 36, which is 46 minus 8, which is 30 what? 32.
Oh, 32.
No.
38.
38?
Yeah.
Yeah. So this is 238. Yeah, correct. 38. Okay. Okay, so this is 44. Okay. So that means 38 equals to square root of 44, square root of 77, and cosine theta. Okay, so cosine theta equals to 38 over square root of 3388. Okay, 44 times 77, can you check? Is it 3388? I think so. So theta equals to cosine inverse, okay, 38 over, this is like 58.2 or something like that. Then this will be 49 by calculator, okay, 1 dp. Always remember, when you have a degree, keep it to 1 dp. Okay?
Okay.